Right, so go ahead, first off, go ahead and pause this. This is straight out of the book. But go ahead and pause this and read these things, and I'm going to clarify exactly what all this stuff is saying. This section is really kind of summarizing and bringing a lot of things together. Alright, so basically what this is saying, this little blurb is saying that you have roots, okay, and zeros, okay, and solutions to the equation f of x equals 0. Basically those are all synonyms. If you have, and actually it's kind of bad form, that's my fault totally. I've been using R a lot for this. So C, they're using C instead of R. R is what I've been using a lot in class. Okay, R comma 0. I've been using R for root. Alright, okay, but they use C. Either way, the point is that if a number is a 0 of the function, a root of the function, or a root of the equation, a solution to the equation, they all mean the same thing. And then actually also that if you have a number that is a 0 or a root or a solution, that x minus that number is a factor. Okay, so these are things I've been talking about a lot. Alright, this is just kind of said, this last section here just kind of throws it all together. All these different things are different ways of talking about the same thing. And then last but not least, also, talk about that too, you know, if you have a real root or a real 0, okay, or a real solution to the equation, those actually will give you x-intercepts of the graph. And so here's a little quadratic example, and I chose quadratic because it's stuff that hopefully you guys would feel pretty comfortable about, as we did in the entirety of chapter 5 about. Okay, so I plotted the same graph twice, same function twice, but in two different formats. So if you notice, x squared minus x minus 6 is in purple. It's kind of the standard form of a quadratic. And if you factor it, you get what I have marked in green. And so you notice, it's the same graph. I just wanted to show that the factored form of the graph, the factored form of the function gives the same graph as what I have in standard form, just to represent it. So notice, the x-intercepts are x-intercepts, negative 2 and 3 are the x-coordinates of those. You get x plus 2 and x minus 3. So everything matches out. And then if you solve this quadratic equation, f of x equals 0, so x squared minus x minus 6 equals 0, if you solve that, you get solutions in negative 2 and 3. You could tell, you can solve by factoring, pretty straightforward because I've got the factors right here. Alright, and not only that, if you notice, if you remember the discriminant, which is b squared minus 4ac, okay, so here it's a is 1, b is negative 1, and c is 6, okay? So you throw those numbers in there for this quadratic, so this is all chapter 5 stuff, but of course quadratics are specific types of polynomials, so this stuff applies. It works out to be 25. So if that means you get 2, when you get a positive perfect square, you get 2 rational roots. Alright? We talked about that in chapter 5. Because this is, the answer here is a perfect square. So anyway, this is a little bit of an aside, but I'm trying to link everything together that we've been working on the last couple of chapters. So the roots are negative 2 and 3, because those are the numbers that you can plug in to solve the equation. The zeros are the same thing, negative 2 and 3, and they correspond to the x-intercepts that you see here, and they correspond to factors of x plus 2 and x minus 3. Notice the only things that are oddballs are the factors. Alright? All the other numbers are consistent. So the roots are negative 2 and 3. The zeros are negative 2 and 3. The solutions are negative 2 and 3. The x-intercepts have negative 2 and 3 involved for the x-coordinates. But the factors are x plus 2 and x minus 3. They're the oddballs. Alright? So anyway, this section is all throwing all this stuff together. It's all the same thing. And so we actually introduced what's called the fundamental theorem of algebra in this section. And all that basically says is that, hey, if you have a polynomial equation, a polynomial function, right, the polynomial function or polynomial equation will always have at least one root, at least one solution. It might be a complex number, it might be complex, it might not be a real number, all right, but you know, maybe it's plus I and minus I. will have at least one. All right? So that's the fundamental theorem of algebra. If you have any sort of equation that has a polynomial in it, you're going to have at least one answer. So a lot of what you have to do is stuff we've already been doing. All right? And the difficulty of problems range from Algebra 1 stuff to stuff we've just really been doing in the last couple sections. All right, so let's do some relatively straightforward stuff. Or beginning, first one, just a regular quadratic. So we can factor this. Okay, we can solve this equation, x squared minus 8x plus 16. So if we factor this, so you might, if you want to practice factoring, pause it. And then if you don't care, I will just flat out give it to you here. All right, but I would pause it. If you want to do it, pause it. All right. But this is x minus 4, x minus 4. So I'll write x minus 4. Heck, it's twice, so I'll just write it out. Squared equals 0. Or I won't write it out twice. It's silly. It's x minus 4 times x minus 4, which is x minus 4 squared. Okay. By the way, so here's your factor. That means that if we solve it, we get, solving by factoring, we get x minus 4 equals 0. So x equals 4 is our root or 0 or solution. Okay? So the factor is x minus 4 for this polynomial equation. All right? And the root, 0, whatever you want to call it, the root of the equation, the solution of the equation is 4. The 0 of the function, if you consider this to be a function, f of x equals x squared minus 8x plus 16, its 0 would be 4. Okay? And this actually is called, since it kind of corresponds to, this is called a, well, I'll type it, I want to write it out. It's called a repeated root. Okay? Because of the x minus 4 squared. It's kind of like 4 is a root twice. Even though that kind of doesn't make sense to put it like that, but that's the way to remember it. Okay? Alright, so that is there's one root. Okay? And it's one real root. So I can actually do the 1. Okay? So this one looks like a difference of squares. We've seen one, hopefully seen one like this already. Alright, x to the 4th minus 1. So we can solve this by, and I lost my pen, oops. So it's x, and you can consider this actually to be a difference of squares, but it's also a quadratic in form because this is x squared squared here. That way we consider this to be x squared plus 1 times x squared minus 1 equals 0. I'm having technical difficulties with my stylus. Can't write worth a darn. I'm going to fix this. Hold on, I'll pause and fix this because this is annoying. Okay, so that was disgusting. Sorry, I had to fix that. That looks much better now. So we can continue factoring this guy, or we can just use, just to go, can remind you of this other way we had to solve. I'm trying to link this to chapter 5 a lot here, or previous chapter here. You can solve both of these factors. We don't have to factor completely necessarily. I could say, all right, x squared plus 1 equals 0, and x squared minus 1 equals 0. Okay? We could do that by difference of squares, the second one, but we can use what's called the square root method, if you remember that from chapter 5. If you don't, you can look it up. Go back in your notes or something. Okay? But both of these are square root method problems. Okay? See if I can make this a little better. Alright, so we have x squared equals negative 1, which means you plus or minus the square root of that, you get x equals plus or minus the square root of negative 1, which is I. So there's two imaginary roots. Alright, and we get x squared equals 1. So x equals plus or minus 1. So you have two real roots. So notice there are 4 total roots. Okay? 2 real and 2 imaginary. So I won't write that out because I feel like I'm worried about running long, but that you would have to. It asks for the types of roots. So there are 4 of them, 2 real, 2 imaginary. And I pointed to the wrong ones, but you know what I mean. 2 real roots, 2 imaginary roots for 4 total roots. Last but not least is this one. This is about as hard as they get, I think, for you guys. Well, no, the next one I'm going to do is also pretty tricky. But it's ones that you guys hated. It is, you know what, actually, I take that back. I've only got 4.5 minutes left, really, for a 15-minute video. So, never mind. I'm going to nix this one. This is something maybe we can do together in class. Let's do this. Okay? So, educated guesses. We've talked a little bit about how to make educated, or how you can factor things that are degree cubic or 4th degree or something, but you got to know one of the factors first. That's what we did earlier in the week. You had to know a factor, and you can use synthetic division to figure out what the other factors were. All right, so the helpful fact on the right is what you need to read and understand. Basically, if you're going to have an integer, you got it narrowed down to what factors of the last term. So you might as well just guess factors of the last term. And actually we can narrow it down even more than that, but I didn't want to get into that yet because that takes a little bit too long. We'll talk about it in class. All right. So I chose 1 because 1 is a factor of 4. All right. And so we just start doing the synthetic division, synthetic substitution. So we do that. Follow along at home. And we have a remainder here of -1. So this is not going to work. And remember what I mean by that is what we've been doing this week is it's not going to work because that's got to be 0. The remainder has to be 0 for x minus 1 to be a factor and for us to help us out. All right. So let's try one I know that will work. Okay. It is 2. Okay, another factor of 4. So you only have a handful of guesses that you know, possibilities. All right. And here we go. There we go. So one factor is x minus 2. Okay, because we got 2 as a root, and then what's left over is x squared minus 2x plus 2 equals 0. Okay? So then, what you have to do is find the other ones. So first root is 2. And so you circle that. It worked out. That's a horrible circle. That's a good circle, but it's too big. Alright, boom, first root. The other roots you got to figure out by trying to factor, and actually this is not factorable. If you use a discriminant, you get a negative number, so that's 2 imaginary roots. Okay, so you got to use the quadratic formula. I'm going to pause it and put it up here because I'm running low on time. Alright. So I quadratic formulated it, and so we got down to this. Okay, so pause it if you need to and look it over and see what I just did. And then so we get, finish it off, 2 plus or minus the square root of 2i, or excuse me, the square root of -4 is 2i, all over 2. So you get x equals, well, 2 over 2 is 1. 2i over 2 is 1i, and there you go. We have 1, 2, 3 roots. 1 real root, 2 imaginary roots. Notice the degree was 3, so we should have 1, 2, 3 roots. 1, 2, 3 solutions, 1, 2, 3 zeros, whatever you want to call them. All right, notice that is how it's supposed to work. All right. Repeated roots are counted each time. If you read this, polynomial of degree n is going to have n roots. So here is a 2-root guy, because you count repeated root twice. Here's for a 4th degree, we have 1, 2, 3, 4. And for this cubic, we had 1, and then 2, 3. Alright, there you go.